in this video we're going to talk about mean absolute deviation, and we've talked about centers of spread and how we use the interquartile range and how we can use numerical and graphical distributions to show data, but the mean absolute deviation is another way of showing data. So we have this really long definition here. The mean absolute deviation is a numerical measure of spread that shows how much data values vary from the mean. A low MAD, and MAD is just another way of saying mean absolute deviation, indicates that the data points tend to be very close to the mean and not spread out very far from the mean. Or not very far. So the mean is an accurate description of typical. A high MAD indicates that the data points are spread out over a large range of values. So you want to find the MAD, or the mean absolute deviation, and see if it's low, and that means that all the data points are close to your mean, or your average. If it's high, then it means they're really spread out. It means there's a bunch of outliers. So let's look at what are the steps to finding the mean absolute deviation. First one, find the mean. So you're going to take all your points, add them up, and divide by the number of points. Then you're going to subtract the mean from each piece of data. Next, you're going to find the absolute value of each difference. Then you're going to add up all your differences. You're going to find the mean of the new differences, or deviations. Deviations just means spreads. Okay, so let's do an example. And we're only going to do one example in your notes because tomorrow in class we're going to do a whole bunch. Alright, so here's an example of MAD, or mean absolute deviation. So let's take the numbers 1, 2, 4, 8, and 10. Okay, so step one, remember, is find the mean. So if we add 1, 2, 4, 8, and 10 all together, we get 25. Remember, to find the mean, you take the number, add them all up and divide by the number of numbers. Well, 25 divided by 5 is 5, so the mean is 5. So now I'm going to put everything into this nice little chart. So here's all my data points, 1, 2, 4, 8, and 10. Okay, so remember step 2 was to subtract the mean from each data point. So here you see for step 2, I took 1, subtracted 5, I got negative 4. Then I did that for each of the other data points. So 2 minus 5, I got negative 3. 4 minus 5, 8 minus 5, 10 minus 5. So now that I've done all of step 2 and I've subtracted the mean from each data point, I have this whole new set of numbers. That's step 2. Step 3 was to take the absolute value of each of my new numbers. So if I take the absolute value of negative 4, I just get 4. Remember, absolute value is always positive. So I take the absolute value of all 5 numbers. Okay, now I'm going to total up these 5 numbers. So when I add 4, 3, 1, 3, and 5, I get 16. Okay, so remember step 4 when finding MAD was to take the mean of this set of numbers when totaled. So now I'm going to take 16 and divide it by 5. I get 3.2. My original mean was 5. My new mean is 3.2. So that means I have a low mean absolute deviation. So that means that they're very close together. And we can look at that. We see that our data points were pretty close together, 1 to 10. That's not a very big range. So that means that it was pretty typical. If this number had been something like 25, then that tells us that our numbers were farther apart. And that is mean absolute deviation. Now be ready tomorrow in class to put those steps to work.